Hello people! Now I'm going to show you some amazing stuff. This is regarding wing and ground effect vehicles. This is my idea of what a large wig should look like. As you all know, wigs are actually boats that fly very close to a surface, water surface, either water or land, and they operate under maritime law rules and regulations. So I've got my little vessel here. It's 120 meters long, it's 40 meters wide. It consists of 4 decks for cargo and people, and it's got a deck in the bottom of the ship, which will have a plant for generating power for the engines. But that's off topic. At the bottom of the screen you will see my project overview of a Airbus Hydrea, which has been designed by the Netherlands, and this is my thoughts on their project and others. So here we've got 5 vessels. We've got the A380, the KM from Russia, we've got the Airbus Hydrea from the Netherlands, we've got the KM2 from my company, and we've got the Pelican from Boeing. Pelican from Boeing is a WIG category C craft, which means it can fly at high altitudes and fly in ground effect as well. These are basic dimensions and parameters of this vessel. Power, weight, and flying operating speeds, and what have you not. I would just like you to know that my craft from the initial has got a little upgrade. It's got 20 meters longer. This is due to the forces of the main wing, which has a lot of torque, and it needs to be counteracted by the canards, and the canards had to be moved forward to counteract these forces. So on the bottom of the screen we can see in relationship the 380, the KM2, which is mine, the KM from Russia, the Airbus Hydrea, and lastly we've got the Pelican, which is a massive aircraft. I doubt that we'll ever see skies. In any case, we've got cross sections here of them flying. We've got some estimation of building the 380, 8.8 billion euros. That is what is initially set out for it, but before the first one flew, $11 billion was spent. Now this is due to aircraft rules and regulations from EASA. This is very complicated and so forth. So here at the bottom we've got a map detailing Dubrovnik from Croatia, the airport, not the seaport. We've there got my KM, the Pelican, and we've got the Airbus Hydrea, which are very, very large craft. Sorry for the noise. I need to keep everything going here. So let's get back down to the document below. As you can see, these aircraft are too large to navigate in ordinary ports. I don't know how to get the sound down from this. And just 1 second. Is it going down? Okay, we've got lift up on the top screen. Engines have quieted down a bit. A lot of air noise, you know. So what else do we have here? Airbus Hydrea. The problem with the Airbus Hydrea, it doesn't leave the water surface. It's always got its blades in the water. These are very, very large. I think also unrealistic. They have an aerofoil. The aerofoil shape doubtfully will work. I I think, to my experience and knowledge of this craft. It's too large, too fat and too long. So coming up with the Pelican. Okay, construction wise, this aircraft is 150 meters wide. It's got a wingspan which is enormous. Building an aircraft that size is going to take a lot of knowledge, training, new technologies, which I don't doubt anybody will be able to use. At the bottom you can also see an Airbus parked beneath the wing. This is just to get a comparison of what they're dealing with. Also, I've calculated some of their specifications. The Pelican engine torque and the power they have and the shape they're trying to push through the air don't make too much sense. But in any case, they've done it. It's their project. Back to my project. As I told you, there's some changes. You can see I've got less engines. I've made dual propellers, but smaller propellers. The aircraft is longer for 20 meters, and it's actually narrow for about 10 meters. This aircraft here is about 10 meters, 50 meters wide. I've went down to 40. Of course, it wasn't sufficient. My craft also weighs 1,300 tons, which is a good 500 tons less than the Pelican. So, okay, I've got some range, some fuel usage. This was still when it had gas turbines, which I doubt was a good idea. I've got some aerodynamic calculations done. I've actually done a comparison to steel versus aluminium construction. These scales of aircraft definitely should be built with steel. I mean, I think I calculated to have 10 tons more frame with steel construction than aluminium, and aluminium, as you all know, is metal with a lot of issues and problems, as I show later on. These are just basic water displacements and lift capacity of hydrofoils. This is the one in the green is the Airbus Dreyer wing, which they are using. The problem with this wing, it's a very fat, it's got a high ratio, and high ratio wings don't really work at low speed, so they need a lot of speed, and I'm not talking about 100, 200 knots, I'm talking they need to go very, very fast. Oh, something happened with my aircraft on the top. Oh, it's still flying. I'm going to try and keep all this together so it's not too boring. It's a lot of texture. My max takeoff weight is not 1,000 tons anymore, it's 1,200. I've got a nice, better wing, a little bit more spacious, a little more friendly to the air. I had to lose about 60 knots on the top speed due to this aerofoil shape. As you can see in the initial project, I tried to go to 400 knots, which was working on the smaller one, but the wing generated so much torque, the canard was pushing down, generating in effect more weight. So I had to increase the length of the aircraft so I have more leverage with the canards. These are just basic static and hydrodynamic forces on the wing on takeoff. As you can see here, the 400 knots again, not going to happen. 360 knots is 300 knots is the speed to go. 360 knots is already pushing it. The main thing, this craft is built on the maritime laws. cheap, quick, fast, and no problems. When you compare it with the Airbus A380, which took many years, I think half or 90% of the technology used on the Airbus A380 is obsolete by the time it went into production. It's something to think about, but it's documentation on the end. Here we've got the oasis of the sea, and next to it parked my W.I.G craft, which actually looks very nicely. Here my comparisons for steel and aluminium, costs, hydrodynamic lift, and what else do we have? Oh, things are going. This is also a very green craft. Pushing winging ground effect vessels through the air is much easier than pushing them through the air at altitude, normal aircraft, so they should use less fuel. These craft do not crash, they simply reduce power and land because the landing strip is always beneath them. Operating in high winds, obviously, problem. Better you go fast. What else do we have? We've got our decks here. This is the lower deck. I've decided not to make it a cargo on the screen above. You can see it's a passenger. Below this deck is the equipment deck, which will be the deck for creating fuel for flight, because I think to go with hydrogen powered engines, not hydrogen powered, they will be electrical powered, but to have a plant actually that will produce hydrogen to feed the electrical system to power the engines will be a very efficient way to go. But as you can see, we've got 1,020 meter square footprint, net area, plus you need to add the 20 meters of extension to the aircraft. Here the next deck has 1,400 square meters plus the 20 meters we need to add, obviously, as for containers, and it can be whole container, half passenger, depends. The layout is up to you. The full deck is actually the third deck. I've managed to put in 1,750 passengers. This is not economy class. Economy class consists of 32 inches. We have here 45 inches spaces in between the people, and it's enough. It's not business class, but it's definitely not economy class. But this is our area. If somebody wants to calculate this into feet, I don't understand feet. In any case, we've got an upper deck as well, 1,440 square meters, plus they added obviously 20 meters in length, 314 VIP, very luxurious, very spacious. Obviously no galleys, no toilets are drawn in here, but space is more than sufficient. Here we've got a parent of the 380 fitting into this airframe. Now this frame is 20 meters wide and 12.5 meters high, so that is a lot of space, and that's a lot of space to push through the air. It's almost a boom. Okay, if anybody wants to buy a VIP, it's in the reach. Why we need these crafts? Well, I don't know if you've seen these projects. They're called lily pads. There are some people that believe we're going to sink in the ocean, and they're building ship-like islands to house people, habitat, and so forth. So it will be nice to have a craft of this size carrying people and furniture and stuff around in between these islands. So let's get back to my ship slash aircraft. I think it's very elegant. I've got the cockpit up at the tail now. I used to have it in the front, but due this craft entering ports and so forth, visibility is an issue, and what do you want to do with a 20 meter wide cockpit? So I've got this one upstairs. It's a bit cramped. It's only 2.1 meters high, so it needs to be a bit bigger. But the overall dimensions are there. We are going in for a landing now. I'm going to try and fast forward. We are moving at 360 knots. Let's get back in the cockpit. Our engines are half power, so they're fuel efficient. This is our height above sea level, so we're about, it looks like 60 feet above sea level. Very low. You can see our shadow. They should call these things shadow chasers. Sorry about the propellers. I think the screen capture is screwing my computer. This is my laptop at home, so be patient. So we're definitely going in for a landing now. Reduce speed. I'm gonna fast forward a bit. Oh, there we're going down. There, 120 knots, shift 8, let's go out of it. Ooh. Okay, maybe we're fast. Okay, there we go. There we go. Touchdown. Control 2 to see the front moving towards us. Once again, the propellers. I don't know what else happening with this simulator. But in any case, Google, don't be angry for me using your Google sign. I couldn't think of a bigger company to take control of this. Oh, well done on your robotics. Very good. So, take a little walk around. Massive vessel. Oh, entry. You can see on the doors on the wings. Obviously the windows will be much bigger. These are basic small little windows, not a bit bigger, but we don't have compression issues. We don't fly at altitude, we fly across the Atlantic, low level. So I hope you enjoyed my video. I'll have some more. Cheers.